Good morning, good afternoon, or good evening, depending on where you're sitting right now at this very moment. Like Richard said, my name is Rodrigo, and today I want to tell you about what happens when you take Python and you join forces with APL and thus get Py'n'APL. Now, before we jump right in, I'm going to stutter a little bit because even though I love talking and I love presenting, I always get a little bit nervous, but hopefully it will pass as I as I talk and present. And other than that, I think that Richard said pretty much everything that's worth saying. My work with Dyalog is mainly on the APL community side of things, so I guess we could call you could call me an APL evangelist and an APL teacher. And I think that the most relevant work I've been doing has been working on the online version of Mastering Dyalog APL and a couple of YouTube series, one on implementing neural networks from scratch with APL and another running series on solving lead code problems with APL. And then I also do the occasional workshop or webinar and, well, related things. Now, I'm going to take one page off of Aaron's book and I'm going to ask you something. So what if I told you that APL is not the only programming language? And more specifically, as you probably picked up by the title and also by my introduction, what if we took Python and combined it with APL? What can we get? What would we get? And now, so Python, I'm describing it here as the language of the people. And if I take it and then I combine it with APL that I'm describing here as the language of the gods, I will get Py'n'APL, which is the focus of this presentation. Now, an important disclaimer is that these two short descriptions are my own views, and I don't mean these two things as opposing views. So I'm not trying to oppose Python to APL. I'm just putting them side by side. And when I say that Python is the language of the people, what I actually mean is that there are literally millions of Python developers around the world, and Python is widely regarded and widely understood to be a language with a low barrier to entry. So it's accepted by the community that Python is an easy language for beginners. And when I say that APL is the language of the gods, I don't mean that only gods can write APL. First and foremost, because I'm not a god and I can write APL, but because you feel like a god when you write APL. And again, this is obviously from my own experience, but bending arrays to my own will, like APL allows me to, I just feel like a god because I feel like everything is possible. And so now talking a little bit about Py'n'APL, what is Py'n'APL? So Py'n'APL is a bidirectional interface between APL and Python. And what this means is that I can use APL from within Python and I can use Python from within APL. Now, I see that a question just popped up, but I'm terrible at multitasking. So I'll be sure to give you a couple of minutes for some Q&A at the end, okay? And now, please do not mistake the purpose of my presentation. So I'm not presenting this or I'm not making this presentation as if Py'n'APL were a new thing. Py'n'APL was actually made by a summer intern, I think 4 years ago. And Py'n'APL was already presented in a webinar and also at a user meeting. So if you've seen that user meeting or if you've been there live, raise your hand, even though I won't be able to see your hand. And the purpose of this presentation is to let you know that Dyalog wants Py'n'APL to be alive and well. And so I have been tasked with picking it up, cleaning it up a little bit and maintaining it and making sure that the community is able to do great things with this tool. And I think it's important to notice or to let you know that Py'n'APL is open source. You can find it on GitHub and it has a very permissive license. So feel free to use it and abuse it and share it and let others know, and you can try to break it and you can try to fix it, you can contribute, you can help. Almost everything, almost anything is possible. So now, why would you care about Py'n'APL? So why is it relevant? What is it? What's in it for the APL folks? I don't know if you know the XKCD website, but there's a comic there that tells you about Rule 34 of the internet. And Rule 34 of the internet says that if you can imagine it, there is porn of it. But actually, or in the present day, there should be a very similar rule that says that if you can imagine it, there is Python code for it. And I say this because if you go over to pypi.org, which is the Python package index, you can find that, or at least a couple of days ago, you could find that there were a staggering 337,213 projects available at a command distance. So these projects, all these projects, you can install them with a single command, and that means that you get access to all these packages to use with Python. Now, for those of you who don't know, a Python package, you can think of it, it's similar to a workspace that you can load and use, or perhaps more appropriately, it's similar to a scripted namespace that you can link to your user session and then use. So with all those packages, what do we get access to? So what kind of potential are we going to tap into? Well, it's fair to say that a big part of the Python community is composed not of software developers or computer scientists, but all other kinds of scientists. So researchers that do research on things that are not computer science, and also people that are just hobbyists and they just need to get things done. And sometimes in a very specific domain. And Dyalog obviously does not cover all of those potential use cases. And so when you need something that's very specific to your domain, for example, doing some data input or output in maybe some weird format that's appropriate for your use case, or if you need some specific algorithm, then it's likely that someone else already implemented that in Python. And now this is, you can sort of notice an interesting loop here, because Python has all these packages, and that's why people who are not computer scientists end up starting with Python, because they already have much of what they need implemented. And so they start with Python and they work on their fields, and then they implement something else in Python, and then they share it. And now you have one other package that's one more piece of software that other people can start with. And so you have this loop that just keeps feeding itself. And not only you have all things domain specific, but also lots of API wrappers are written in Python. And so what this means is that services, for example, like Twitter, that offer an API that you can call, many people, well, sometimes the services themselves, they implement wrappers in popular programming languages like Python, or sometimes the community writes a wrapper. And so things like the Twitter API or the Twilio API or the Google Drive API or the AWS APIs, all of these can be easily accessible from within Python. And it's more convenient than using the raw API with all of those weird requests and things I don't even really understand a lot of. And then something else that, from my personal perspective and from my very limited experience, I feel like would be a huge area where Python and APL could play together, is when we think about artificial intelligence and machine learning and deep learning and reinforcement learning and data science and computer vision and all those fields that are very popular right now. I think Python and APL can play really well together here. On the one hand, we have plenty of frameworks and libraries that are available in Python. I was about to say written in Python, but they're probably written in a fast language like maybe C, and then you have high-level access to those frameworks and algorithms from within Python. But then something else that XKCD tells us is that machine learning is essentially a pile of linear algebra. And the APLers among us will know that that's one area where APL really shines. If you have some code that is very linear algebra centric, APL is amazing at that. And so if you have all these libraries, then you can probably use APL to maybe prototype new algorithms, or just do the pre-processing of the data, or just do new kinds of experiments. And so going to what Python has to gain from the ability to use APL, we have that I just mentioned, and then an answer that is not very, it doesn't tell you exactly what you could do with APL, but definitely proves that APL could be useful. And that's the innate ability that APL gives you to bend arrays/data to your will. And I say that this is obviously something that APL has to offer to Python, because Python does not have built-in support for higher dimensional arrays. You only get lists, so like something similar to vectors. But Python has this module that's called NumPy. That's the de facto standard module that you use in Python when you need arrays, so matrices, 3D arrays, etc. And without belittling APL, we can kind of say that APL is like a NumPy on very strong steroids. So if NumPy is useful for Python, APL certainly can be useful for Python. And then another thing that really drives the point home is that if Python is already known for being a language where prototyping solutions is easy and fast, then you put that together with APL, which is another language where prototyping is easy to do and fast, and you get an awesome combination. And the point here is that even though I have a couple of demos to show you, I need your help because my imagination can only go so far, and I'm pretty sure that all of us together can come up with very interesting usages of Py'n'APL. And so without further ado, I think we can jump straight into the demos I have. There's 4 of them, and all of them are available on the GitHub repository where Py'n'APL lives. So I'll just show them to you, but you'll be able to play around with them later. And these are the 4 demos we are going to do. I'm going to be using APL from within Python for the first 2, and then I'll be using Python from within APL for the last 2. So what I'll do now is I will stop sharing, and then I will share the appropriate screen where I have the things I want to show you. So let's see if I can share this screen. Yes, I can. So you should be seeing my code editor right now. And what we have here is, yes, exactly. And what we have here is it's a Python file. So it's a file with Python code. You can go up and down. You can see it's 140 lines of code. And this is an array heavy simulation. So I'm going to be simulating Conway's Game of Life, and the Python code is driving the simulation. So it's, for example, it's handling all of the user events over here. And then what APL is doing is the computation. So the heavy lifting is done by APL. For example, we can see here on line 71, a very well-known expression that takes the simulation state and builds the next state. And one of the things I find interesting about this code is that while APL is building the next state and doing all the computations, we get up to this point where, I don't know if you can see it, but over there, this is the where primitive. So over here, what I'm doing is I'm figuring out the positions on the board that need to be updated. And then I'm using the where primitive to actually get the coordinates. And I'm pulling that information back to the Python side so that I can then paint the screen on those positions. And so enough talking. Let's get this to run. Game of Life. No, oh, right. I should plug my computer in, right? I don't want to get out of, okay. Very important to plug the computer in while doing a presentation and while low on battery. So this is the simulation window, this gray thing right here, and we can draw something and we can get the simulation to run, or we can just fill the board randomly and have it play it out in front of us. And again, Python just does the event handling, and APL is doing all of the computations. So that's it for this specific demo. And now the second one is also using APL from within Python. And now what I want to do is I want to recognize automatically the language in which a sentence is written. So I'm just going to have that run to load the data. So what this thing does is, I don't care about the changes. So this program right here, you write a sentence in a natural language, and it tries to predict if the sentence is English, French, Spanish, or Portuguese. And the way this works is really simple. And so sorry, just a tangent. With this specific demo, I'm demonstrating the ease with which you can prototype in this particular case, an artificial intelligence algorithm with APL. It's a very simple algorithm, but it still drives the point home. So what we have is I have 4 files like this. This specific one is for Portuguese, and I have trigrams. So I have sequences of 3 characters, and then I have counts. So I didn't look. So this is how the data was gathered. People looked at a lot of Portuguese texts, and they figured out how many times each trigram appeared, and now I can compare the trigrams and figure out, for example, that these 3 letters appear much more often than these 3 letters. And I have files like this for all 4 languages. And so when I type in a sentence, I run this little bit of Python code. So this here is the sentence, and then I do a 3 concatenate reduce. And so what this does is it breaks the sentence into trigrams, and then I'm using the index of primitive to figure out where in the column those trigrams live, and then get the associated counts. And then with that, I can use some basic probabilities to figure out what was the language that was more likely to have produced that sentence, given that I observed those specific trigrams. And so I can type something here, something like, maybe this is not big enough. So let's make it really large. So hello, I'm at the bottom of the screen now. Hello, my name is William. And so it recognizes the sentence to be in English, or I can type something like, Olá, o meu nome é Rodrigo, and it recognizes the sentence correctly as Portuguese. Now, obviously it can fail. So for example, banana, this is both Portuguese and English, and probably also Spanish, and it gets recognized as Spanish, or I can check in like just a single word, chocolate, chocolate, which is also the same in, except I can't spell. Okay, chocolate, this is also Portuguese, but also English, etc. So yeah, it's not perfect, but it's quite an interesting algorithm. So that's it for these two demos. And now let's jump right into the APL session. If I manage to open one, which I have. And now what I want to do is I want to revisit a piece of code I wrote in my webinar. So I did a webinar on drawing the Mandelbrot set. And now what I want to do is I want to link a folder with a couple of functions to my user session. So give me a second to think. Dyalog, and then Py'n'APL, and then it lives in the demos. All right, and now what I can do is I can show you the functions I brought in. So -4. Except this is not what I wanted. So let's just show you everything. Okay, so I brought in 3 functions from the webinar and an extra function that is specific for this demo. And so now what I can do is I can build a fractal. I just need an auxiliary variable, and then I'll build my fractal out of the Mandelbrot function that implements the proper algorithm to figure out how the fractal looks like, and then the grid to build an auxiliary grid. And then I can use my palette function to build a color palette because I want the fractal to be colored. And this builds the palette. And now the image, because the whole point of this is to generate an image, the image you can make it by just taking the palette and indexing it to it. And now I get a 3-dimensional array. And the 3 major cells represent the red, green, and blue color channels of an RGB image. And at this point in the webinar, what I wanted was to be able to save this image as a PNG. Of course, I forgot to delete it. So this is what I want to produce. I want to be able to produce this PNG. And for the webinar, I had to go online and look for APL code that did this, because Dyalog does not support PNG, the PNG file formats. And I was able to find out a namespace. So the point of this specific demo is not to tell you that now it's much easier to handle PNGs because it's already possible to do in APL. It's just to show you that when you need to work with file extensions that are not the ones that Dyalog knows how to handle, you can go to the APL side and, sorry, you can go to the Python side and look for packages that handle those file formats. And so my create image function is actually 3 lines of, we could call it Python code. We just import 2 packages, and you can see here NumPy over here. And then we just pass in the array to the APL side, and then we save it to the path that we specify. And so if I want to use this, let's not do any changes. If I want to do this, what I need to do is I need to load now let's copy the path. I need to load Py'n'APL into the APL side. And this is not, again, this is not a tutorial on Py'n'APL. So you can watch Marinus's presentations on Py'n'APL, or you can read the GitHub README. So now what I'm doing is I'm loading Py'n'APL and I'm changing the directory to this one. And now I'm connecting to Python. And now that I have my Py instance, what I can do is I can call my function. I can give it the image and the path where I want to save it to. And it can run. Now, again, the purpose of this specific demo is not to show you how much easier it is to handle PNGs now. It's to show you that you can usually handle pretty much any type of file extension if you use Python. And after this runs, you can see that the image is in here in my file system. So that is it. And now for my final demo, this is from the algorithmic point of view, this is probably the least interesting, but from the practical point of view, it might even be the most interesting. So what I have here in front of you is a spreadsheet that's on Google Drive, and it contains some dummy data. We can pretend that this represents some expenses I've made this week or this month, doesn't matter. And now I want to analyze my data to see how my spending habits are evolving over time, or if I'm spending too much money on a specific category. And obviously, I don't want to have to press buttons to download the data and then import it into APL. I want to be able to do everything automatically. And so what I'll do is I'll leverage the Google Drive API, and in particular, the wrapper that's written in Python. So what I'll do is I'll open a text file that contains the function that I care about. And I'll fix it before I close this. And again, it's just a couple of lines of Python code importing an appropriate module using my credentials to authenticate so that I can connect to the API. And then I'm asking to open a spreadsheet, and then I'm getting all of the values. And I'm going to go ahead and say that even if people didn't know what this was doing, you can almost read this, because there's like the service account and the credentials, so you can guess that we are authenticating here. And then you can see the open and the name there. And so you can infer that we are opening something, and then I'm getting all the values. And then just a little bit of APL code to do some basic data processing. And so if I want to get my data, what I need to do is I need to use my Python instance, and then I need to call the function and give it the path to my credentials, and those live somewhere over here. So let's copy the path to the credentials. Let's paste this and delete this. Okay, so now we call the function, and then we get our data, and I get to, for example, figure out how much money I've been spending on each type of expense using the key operator. And then I can build my, oh, I forgot to close my diff, silly me. Let's interrupt. Now let's fix this. And then I get to analyze my data and just work with it. So this was the 4th demo. I hope this was enough to, now let's go back to my PowerPoint slides. I hope this was enough to whet your appetite. The demos were themselves fairly simple. I just wanted to showcase some of the things you could do. And when you go to the Dyalog website and you download these slides, you will have a series of useful links to the things I've been mentioning. And I'm pretty sure we have some time for Q&A. And otherwise, feel free to reach out to me at any point in time. I'm always happy to connect with other people. Thank you.
Rodrigo, we've got a few questions in the chat. I'll read them out to you. The first one is actually just a comment when you were talking about the language of the people and the language of the gods. Ezekiel Berman said, "Is this the language of the demigods?" A nice observation.
Yeah, maybe.
And possibly if anyone else wants to ask some questions, there's about 4 minutes, so type them quickly. But I'll give you what we've got. Romilly Cocking asks, Rodrigo, have you looked at using this with the JAX framework? JAX makes it fairly easy to run Pythonic array orientated code, I can't read that, in parallel across one or more GPUs.
Well, the very short and accurate answer is no. I haven't looked at using it with the JAX framework. I've picked up Py'n'APL fairly recently, and I'm still trying to get used to the internals. So I haven't advanced. I haven't made much advancements in terms of improving Py'n'APL.
Okay, thank you. And Aaron Sue asks, is the protocol between the Python code and APL code a binary or textual encoding? I'm presuming he's asking about the data transfer. For transferring large amounts of data between the two systems, how much overhead can we expect?
So I cannot at this point in time quantify the overhead because I have no idea. Well, I haven't quantified it yet, so I can't answer that part. As for the protocol that's used between Python and APL, I'm pretty sure that it's binary. So like I said, I've been diving into the Py'n'APL source code, but I'm still getting used to it. And so I wouldn't bet my right hand on it, but I'm pretty sure that the data is being transferred as bytes. And then Shuhao asks if the APL session can use Venv Python. And so I think that Shuhao wants to ask if I'm able to use virtual environments. And I'm pretty sure that the answer is yes, because when Marinus created this, and you can find it on the README on GitHub, when you connect to Python from the APL side, you can specify a path to use the a non-default Python. And so you probably can specify a virtual environment. So I hope this answers your question, Shuhao.